This lesson is for 3.1, and we're going to be solving systems of equations today. So systems of equations are two lines on a graph. And so when you're looking at a graph, the solution is always going to be where the 2 points intersect. So on this graph here, my solution would be at 2, 1. So that point would be the solution to both of these lines. It's where they intersect. And so if you're looking at a table, your solution is going to be where the x and the y values are the same. So if you look at this table here, x is 2 for both of these lines, y1 and y2, and then the y is 4. So in this table, the solution would be 2, 4. So your solutions to systems of equations are always an ordered pair, an x and a y value. And so the first thing that we're going to do is show you how to solve these in a calculator. And so you can put your two equations into a calculator and hit graph. And then if you can't see the intersection, you can use this feature called window, and we'll practice with that. All right, so down at the bottom, we're going to find the intersection on a graph already given to us. So if you look where these 2 points meet, they meet at 1, 3. And so that would be your solution to that graph. Now, if they give you two equations, you're going to have to put this in your calculator. So in your calculator, you would go to y equals, and you would put both of your lines. So 3x plus 2 would be your first line. And then your second line is going to be x plus 4. Now, from there, you're going to hit graph, and it's going to graph both your lines. And we can see where they cross on here, so we don't need to zoom out any. And then to find the intersection, if you hit second, trace, and then we're going to do the intersect. So you hit 5, and you're going to hit enter 3 times. So 1, 2, and then 3. And you can see here where it says intersection, and it tells me at the intersection, the x is 1 and the y is 5. So the ordered pair or the solution to this system of equations would be 1, 5. The next note page you have is solving linear equations. And so we've got these 3 examples here, and we're going to solve them, and we're going to use our calculator. Now, the first one we're not going to do, but example 2 we can do in our calculator. So let me clear my calculator. And so again, you go to y equals, and we're going to type both of our equations in. So x plus 1, and then y2 is negative 1/2. So remember to do a fraction, alpha y1, and I can put 1/2 in there. Then get out of your fraction to put your x, and then plus 4. And then you're going to do graph, and make sure you can see your intersection. And then second, trace 5 will give you the intersection. And then you have to hit enter 3 times. So 1, 2, 3. And you need it to say intersection down here. So the solution to this system of equations is x is 2 and y is 3. So as an ordered pair, that looks like 2, 3. All right, example 3. So clear my calculator. I'm going to go into y equals. So now I've got a negative 1/4 to 1/4 x, and then plus 3. And then my second equation is negative 7/4 x minus 3. So once you type them in, graph, and wait for your graphs to show up. And then second, trace 5, and then enter 3 times. So 1, 2, 3. And so now it tells me here that my intersection is at negative 4, 4. So as an ordered pair, negative 4, 4. All right, so there's different types of solutions. So you can have one solution, and that's where your lines cross and they meet at one point. And so if you look here, here's my intersection already marked for me. And so my x would be negative 2, and my y would be a positive 3. So negative 2 comma 3. Now you can have no solution. And so lines that have no solution have the exact same slope. They have a different y-intercept, and they're parallel lines. So if you can remember from elementary school, parallel lines, they never touch. So they're never going to intersect. There's never going to be a solution. And then when you have infinite solutions or infinitely many solutions, the lines are going to have the same slope, the same y-intercept, and the lines are exactly the same. You're graphing the exact same line twice, so they overlap. So every point on this line is a solution. And that is it for this video.